You know that picture we all have in our heads? Sun right in the middle, planets doing these neat little circles around it.
The standard classroom model.
Yeah, exactly. It's simple. It's how most of us first learned it. But looking at the material you shared, that tidy image, it might be selling the universe a little short.
Absolutely.
Hmm.
I think when you really delve into these sources, what becomes clear is just how much more dynamic and, well, surprising our solar system truly is compared to those basic diagrams.
It's amazing how stuck that image gets in your head, isn't it?
It really is. It serves a purpose initially, but
Right. So that's what we're doing today. We're taking a deep dive into let's say, the real mechanics of our cosmic neighborhood. We'll look at the actual movements, the forces involved, the stability of the whole thing.
and what it all means for, you sitting there moving through space right this second.
Exactly. The sources you sent over, they really paint a picture of just constant, relentless motion.
They do. It's about understanding that what looks static or simple is anything but. It's this cosmic ballet on a truly grand scale.
Okay, so let's tackle that potentially misleading picture first. Those diagrams, the ones with the perfect circles.
Yeah, those ones.
Well, one of the first things your sources highlight is that those orbits, they aren't actually perfect circles at all.
Right. That's a key point. They're actually ellipses. Sort of like, well, slightly squashed circles, you could say.
And it's not just the shape of the path, is it? It's the speed, the incredible speed.
Oh, definitely. We all kind of know Earth spins, right?
Right.
And it does,
Yeah.
remarkably fast.
Yeah, spinning you around at, what, about 1,000 miles an hour, depending on where you are. But then, as one of your articles pointed out, you factor in its journey around the sun.
And suddenly we're talking speeds close to 30 kilometers every single second.
Yeah, it's almost impossible to really get your head around that kind of velocity.
It is.
Yeah.
And as another piece of research you shared makes clear, this isn't happening in isolation, the sun itself. It isn't just sitting there.
Ah, yes. This is where it gets really wild based on your materials. Our sun is actually, what was the figure? Tearing through the Milky Way galaxy at something like
828,000 kilometers per hour. It's mind-boggling.
828,000. Wow. And as your sources explain, it's pulling the entire solar system along with it, isn't it?
Precisely. So forget that image of planets moving in a flat plane around a stationary sun.
Right.
Think more like, well, spiraling through space. It's a three-dimensional corkscrew motion as the sun itself moves forward through the galaxy.
So those textbook illustrations, one of your sources even called them flat 2D lies, which, okay, sounds a bit strong maybe.
Yeah, it's punchy.
But it definitely gets the point across, doesn't it?
Yeah.
They're useful for a basic grasp, sure, but the reality is this incredible spiraling three-dimensional dance.
Exactly. It's a necessary simplification, perhaps for introductory purposes, but it just completely loses the dynamism, the sheer energy of the system.
Which naturally leads to the next question based on your materials. What's holding this whole chaotic-sounding dance together?
Well, the big player here, as all your sources agree, is gravity.
The sun's gravity, specifically.
Yes, the sun's immense gravitational pull. That's what keeps all the planets, asteroids, everything from just, well, flying off into the void. It's the ultimate cosmic anchor for our system.
One of the articles you sent, I liked how it described it like a massive cosmic magnet.
That's a good analogy, yeah. This fundamental force dictates the orbits, maintains the overall structure. It keeps everything bound together. Relatively speaking, of course.
Right, because even this cosmic magnet, as that source put it, isn't the be-all and end-all, is it? We talked about the sun orbiting the center of the galaxy.
Exactly. So even that colossal gravitational influence is itself part of a bigger picture, a larger hierarchy of gravitational interactions. It's gravity wells within gravity wells, in a sense.
And the sheer reach of the sun's gravity. One of your papers detailed that. It's staggering it extends over.
Over 15 million kilometers in every direction.
15 million kilometers. Just think about that volume of space.
It's vast. And that sphere encompasses not just the planets we know, but countless comets, asteroids, even tiny particles of space dust. They're all under the sun's gravitational sway, more or less.
So everything within that enormous sphere is kind of tethered to the sun?
Yeah.
Wow.
But, okay, with all this constant movement, this spiraling, this immense gravity that your sources describe, it does make you wonder, doesn't it? Is this whole system actually, stable
Yeah.
long term?
That is the crucial question, isn't it? And it's one that your materials raise in a really fascinating way. There's this intriguing, maybe slightly unsettling idea of these tiny shifts in planetary orbits that scientists have apparently observed.
Yes, I saw that. And as one of your articles points out, there seems to be some debate about what these shifts mean.
Exactly. Some researchers seem to think they're just minor fluctuations, nothing to worry about, part of the normal noise of the system.
But others, well, another source suggests they aren't quite so sure about the long-term implications. They're looking at it a bit more cautiously. And what's really interesting, drawing from the different viewpoints in your materials, is the potential for even small changes to have pretty big effects over, cosmic timescales.
Right. One source was asking these compelling questions like, could a really big solar flare, a massive solar storm, could that subtly nudge an orbit?
Or could a major asteroid impact, say, something hitting Earth, actually alter our path in a measurable, lasting way?
It really challenges that old idea of a perfect clockwork universe, doesn't it? The idea that everything is in perfect balance forever.
It does. Your sources seem to suggest a system that's maybe more dynamic, even potentially a bit precarious than we might think, where even tiny nudges, as one put it, could maybe have knock-on effects.
Like the other analogy, one article used a domino setup across space.
That's a very vivid way to put it, and it really underscores the interconnectedness that your sources emphasize. A small event somewhere could theoretically ripple outwards. It's a complex web.
Okay, so based on everything we've dug into from your materials, we're on this spiraling dynamic system. It's held together by gravity, mostly, but maybe it's not quite as perfectly stable as we used to assume.
That seems to be a fair summary of the picture painted by the sources, yes.
So now let's bring this huge cosmic perspective right back down to Earth, right back to, you listening right now.
Exactly. Because all this incredible motion, this cosmic dance, it isn't just abstract stuff happening way out there.
No, it's happening to you, right here, right now.
Think about it. As your sources remind us, the Earth is spinning you,
At around 1,000 miles per hour.
give or take.
And at the same time, it's hurtling you around the sun at over 67,000 miles per hour.
67,000. We are all literally on one heck of a space journey every second of every day.
And what's truly astonishing, and something several of your sources really highlight, is that we don't feel any of it. Not a bit.
It's completely counterintuitive, isn't it? Compared to being in a fast car or a plane.
Totally. And the reason for that, as your materials explain so clearly, is the vacuum of space. There's no air resistance, no friction up there.
Right, nothing pushing against us to give us that sensation of speed.
It's just pure, unresisted motion. Smooth sailing, you might say, even at those incredible velocities. And one of your sources sums it up with this really powerful image.
Which one was that?
It describes you, the listener, as riding a giant flaming ball through an endless void.
Huh. Okay, yeah, that's dramatic. But, I mean, based on what your materials illustrate, it's not wrong, is it? It powerfully conveys the reality of our situation.
It certainly does. It cuts through the everyday perception.
So, considering all this, the spirals, the gravity, the speeds, the potential instabilities, why dive into these complexities? Why is it important?
Well, as several of your sources articulate really well, it fundamentally shifts our perspective, doesn't it? It's about really grasping our place in the grand scheme of things.
We are, as your sources bluntly point out, just this tiny speck.
Orbiting a pretty average star in just one little corner of a galaxy that has hundreds of billions of stars.
And that galaxy itself is just one among, well, countless billions in the observable universe.
It's profoundly humbling when you actually stop and think about that scale.
It truly is.
Isn't it?
And yet, and this is the amazing counterpoint one of your sources makes so eloquently, within all this vastness, we possess this extraordinary capacity for, well, for talking, thinking, questioning.
That curiosity, that drive to understand.
Exactly. That innate drive is what makes us perhaps unique in all this immensity.
So by understanding the true nature of our solar system, this, dynamic interconnected web of motion and gravity that your materials have illuminated for us, it kind of serves as a constant reminder, doesn't it? We might seem insignificant on the cosmic stage.
But our curiosity, our ability, and our desire to ask questions and figure things out, that seems to be, in essence, limitless.
So maybe the takeaway is this. As you go about your day, just take a moment. Consider that incredible spiraling journey through space you're on right now.
Reflect on those immense forces, that maybe delicate balance that the materials describe.
What does it really mean to be on this giant flaming ball hurtling through the void? And maybe, just maybe, What other flat 2D lies, what other simplifying assumptions might we be accepting without really questioning them?
That's definitely something worth pondering. Keep asking those big questions.